We're going to draw the whole mechanism for the reaction of 2-methyl-1-butene with HCl. It's going to be the same mechanism if you do it with HBr or HI. So the first step of the reaction, following the arrows very clearly, negative attacks positive. So the 2 electrons of the double bond are going to form a bond to the proton, and we are going to attach that carbon to the carbon of the double bond that has more hydrogens, because this reaction obeys Markovnikov. When you break a bond, like we're going to have to break the hydrogen chloride bond right here, we give the electrons to the most electronegative element. So we form a carbocation intermediate, and we always form the most stable carbocation intermediate. This one is going to be a tertiary carbocation. And we just displace a halide. So now we have these two right here, the carbocation and the anion of the halide. And this is the first step of the reaction. And this step, normally it's called the protonation of the double bond. The second step of the reaction, if you always think about negative attacks positive, we have it right here. We have a tertiary carbocation, and we also have a halide ion in solution. So negative attacks positive. The arrow starts on the negative, so you can actually start on one of the lone pairs, and the arrow always points to the positive. Now this step right here, they call it attack of the nucleophile on the carbocation, because the negative species is what we're going to actually keep calling nucleophile. Nucleophiles are looking for a nucleus to put the electrons in. Electrophiles, like the carbocation, those need electrons. They don't have enough electrons, so they want something to bring electrons so that they can complete the octet. So the nucleophile attacks the electrophile, negative attacks positive, and that would be the second step of the mechanism.